Today's pocket edition is affordable, rapid bootstrapping of space industry and solar system civilization.
What kind of species do we want to be? Do we want to be here, chained to the Earth forever? Or do we want to be out there colonizing the solar system, taking our curious blend of culture to the stars?
We can start a space industry, a space economy that does things in space, eventually better and more efficient than we can do them on the planet.
Fully autonomous, self-replicating robots out in space with a giant manufacturing industry, mining resources in one part of the solar system, taking to the other. You know what we need? We need self-replicating humanoids with diggers out in the Kuiper Belt mining for ore. We need to make this happen. If those humanoids are blessed with artificial intelligence and they are out on their own, who knows where in the solar system, with infinity ahead of them, they might well start terraforming under their own guise. It's like, we've long since got rid of those idiots back on Earth. Let's terraform.
It requires a little bit of willingness to be playful and be silly and talk about things that are way beyond our capabilities of today.
And there's a lot of jobs teleoperating all of this industry, all of this manufacturing, high labor costs. So for 4 generations, we're dancing all the way to the bank. But then as soon as the autonomy kicks in, then once again, humanity will be suffering a change in employment.
People want to lean into this, or are they more concerned with building robots that will help people build cars? And, that'll be novelty items in the front lobby of a hotel that'll carry a drink to you.
Disruptors and curious minds, welcome to Thinking on Paper Pocket Edition. And I want to start with a question. What kind of species do we want to be? Do we want to be here, chained to the Earth forever? Or do we want to be out there colonizing the solar system, taking our curious blend of culture to the stars? Because if we want to do that, we're going to have to do some serious manufacturing in space. We're going to have to build self-replicating humanoids on the moon. We're going to have to build diggers on asteroids. There's a lot going on. And today we are speaking about rapid bootstrapping of the space industry and solar system civilization. What can we achieve? How much will it cost? And what are the steps to get there?
Off we go. Today's pocket edition is affordable, rapid bootstrapping of space industry and solar system civilization. Philip Metzger, Anthony Muscatello, Robert Mueller, and James Mantovani. So very smart guys, largely all NASA people, largely all physicists, chemists, that sort of thing. So here's the deal. Here's what I got out of this, and let's just outline where we're going. We can start a space industry, a space economy that does things in space, eventually better and more efficient than we can do them on the planet. But it comes in a couple phases. So starting small, getting stuff off the Earth onto the moon, and then starting simple with this process of, he calls it teleoperating. So basically like remote operating these systems that are built on the moon in small scale, and then scaling those systems with robotics, with AI, and eventually to where we're leaving our jump off point on the moon and then going to the solar system and asteroids and all of that stuff. So that's kind of where we're headed with this. It's literally a moonshot idea. It's really, really a cool idea that won't take a whole lot to get kicked off the ground, which is why it's called bootstrapping. Where do you want to start, Mark?
So in the introduction there, outlined the fact that all of the natural resources that we've used on planet Earth exist in the solar system in multiples of billions. So we don't need to be harnessed to planet Earth and all our resources. They are all out there in space. With this rapid bootstrapping, he talks about generations, steps from step 0 to fully autonomous, self-replicating robots out in space with a giant manufacturing industry, mining resources in one part of the solar system, taking to the other, expanding our footprint, expanding our reach out into space. But that starts with generation 1, and that involves going to the moon and using existing technologies to start building on the moon, essentially, and going from there.
The paper references metric tons. How much stuff do we need to get started with something on the moon that could eventually get us to a point where we're manufacturing in space? We're doing what they call closed loop or full loop, basically meaning that everything manufactured is happening in space and nothing is happening with resources from the Earth. It's kind of doing it all on its own.
Full closure, partial closure, and sub-replicating. Full closure, everything is done automatically self-replicating by machines in space. You have partial, which is people on Earth remotely orchestrating some of this, and then you have like sub-replicating, which is a combination of the two, which this paper is essentially number 3, isn't it? Because it starts with that. So why is the weight part so interesting and so important, Jeremy?
Launch cost, right?
Yep.
Exit velocity of getting the needed pieces and parts to build these systems, but launch costs are coming down right now. I looked at today, the 2025 launch costs based on SpaceX's numbers per kilogram. It was like $4,000 per kilogram.
SpaceX goal is kind of $10 a kilo,
right?
Initial long-term goals, and obviously that makes huge differences. Are you surprised by the actual weight? I was surprised by the weight that they suggest is what we need to begin.
Yeah, 12 metric tons.
Doesn't seem like too much.
It really doesn't. And it's interesting too, the way they together, this group of people, outline the scaling of this. Is it actually is a 2 steps forward, 4 steps back. So 12 metric tons of stuff gets on the moon. We do some stuff remote operated. We get some robots doing some basic things. And then the next generation of that, because we're basically trying to replicate systems. So the first replication of that system is actually less productive than the system we ship up there. And then as we move through cycles of that replication, it gets better, it gets more efficient. The robotics get better, the launch costs come down, and all of those things. But according to the paper, it says within a few decades, we could have millions of times the industrial capacity of the United States, which is like, wow, we can move all of the industrial things off of the planet and mitigate the effects on the climate change and things that could make Earth uninhabitable eventually. Seems really interesting.
To quote from the paper, the goal from that point is to initiate a spiral of technological advancements until the moon achieves its own mature capabilities like Earth's. This evolving approach will provide several benefits. First, industry on the moon can develop differently than on Earth. The environment, the manufacturing materials, the operators, robots, and the products and target markets are all different. Second, the evolving approach supports the development of automation so that industry can then spread far beyond the moon. The technological spiral will develop the robotic workers in parallel with the factories. It will also improve automated manufacturing techniques such as 3D printing. And then the third is obviously the economic one, that the advantages of building on the moon. We're going to print our way to the future. It seems that humanity is very much based on 3D printing. We'll get to the generations of lunar industry in a minute, but quite quickly in this generational arc, there are self-replicating robots using 3D printers to print themselves and the machinery and the infrastructure that they need, which is just stunning. Basically, just robots creating updated versions of themselves out in the Kuiper Belt somewhere.
Once they get to the moon and establish stuff on the moon, there's polar ice caps on the moon, so there is stuff to work with, but it's limited. Once that stuff is gone, that's when they have to jump off and hit the Kuiper Belt and hit all these other places to kind of continue. They're talking about being able to print or being able to manufacture computer chips eventually is the goal. So these lithography machines, we're going to land those on the moon, and robots are going to be making chips. Here's a quote. The objective for the first robotic colonists on the moon to fabricate a set of, say, 1700s era machines and then advance them steadily through the equivalent of 1800s, 1900s, and finally back to the 2000s, which is really interesting to think about. I mean, we're not landing there just trying to do stuff that is 10 steps ahead. This is a thoughtful process of getting from A to B.
There's a very nice quote. We will not start at the beginning and we will not begin at the end. So we'll start in the 1700s and then we'll very quickly, rapidly update, upgrade, advance that technology through the centuries. Speak to me about the generations of lunar industry. I think it's very important to outline the 8 generations that they mention.
Yeah, let's run through these. So generation 1 is we got some stuff on the moon. It's could be locally operated. Maybe we got some humans on the moon as well to initially kick this thing off with a couple of robots. Most of the systems are operated from Earth. That teleoperation continues through the first 3 generations.
What kind of things are they manufacturing in generation 1 and 2?
All of the systems that in that 12 metric tons that land on the moon are the industry, are the manufacturing. So the materials would be gases, water, crude alloys, ceramics, and solar cells. But basically we're importing these fully put together machines, and we're doing that in generation 1 with insect-like artificial intelligence. Some bigger things get imported from Earth. Generation 2.5, we're getting into plastics and rubbers, some chemicals.
Interesting to note that by generation 2, there are no human outposts. It's all teleoperated. The second generation, humans are out of the loop on the ground, on the moon, and it's all teleoperated.
Yeah, some experiments in autonomy. Maybe we're locally building PC cards and chassis on the moon. And then generation 4, we've got some autonomy continuing to happen with some close supervision, and we're into large plants for chemicals and manufacturing and metals. And this is where the potential lithography machines land on the moon from Earth, and we start figuring out, hey, can we make chips? Can the robots, is the dexterity there enough? Can they, the precision there enough? And then we have more loosely supervised autonomy.
So the good news very quickly becomes bad news, because I was thinking, reading this paper, I've lost my job because of AI. If you can't work on the Earth, then you work in space. And there's a lot of jobs teleoperating all of this industry, all of this manufacturing, high labor costs. So for 4 generations, we're dancing all the way to the bank. But then as soon as the autonomy kicks in, then once again, humanity will be suffering a change in employment.
I think to me, that is getting robots to do stuff like that off the planet that doesn't affect the planet. That is a happy offload, I think, for me, at least in my understanding of how everything operates at this point. Then we can do things like host podcasts, and we could read books, and we could teach, and we could write, and we could...
Well, yeah, but it's just an interesting dynamic that we're seeing with AI, or at least people are talking about, with AI taking everyone's jobs. And what will it replace those jobs with? And a lot of the theories of what the jobs AI takes will be replaced with don't hold water for me. But this is a good opportunity to employ thousands, possibly hundreds of thousands, possibly millions in space manufacturing. And then we'll go through another shift like we might do with AI in terms of those jobs disappearing.
Well, so what we'll do is create Thinking on Paper University, with a first course being teleoperated remote manufacturing from Earth to the moon. That's our first class, Mark. So there we go. Okay, so let's run through these other stages. So 5 and 6, we're near at full autonomy in generation 6, where artificial intelligence scale, according to, what was that guy's name again?
Hans Moravec.
Moravec. We're in monkey-like, right? So we've got large-scale self-supporting, and now we're starting to do little jaunts to the Kuiper Belt.
Yeah,
off the moon.
Industry to asteroid main belt, yes.
And then the phase beyond that, we're in autonomous robots that we've set up stations here and there. We're bringing resources back from the asteroid belt. We're zero gravity manufacturing.
You say it's cool, but it's also very, very important for the long-term survival of humanity. I mean, the long term. The sun is going to end one day. And in the very, very slim likelihood that we are still here, we will need to be elsewhere. The idea of self-replicating robots taking their diggers from the moon, hitching a ride on an asteroid, and then slingshotting around Jupiter and catapulting themselves off into the heart of the solar system is actually the only way that our strange, curious culture will live forever. So to take manufacturing in space to the next level, we need a lot of things. And I jokingly at the beginning said diggers, but
diggers.
The first thing that they need is excavators. The excavators will travel between the digging site and the resource processing site, delivering sufficient lunar regolith each hour to maintain production rates of the other assets. The details of the excavators are unimportant. In our modeling, we assumed for specificity that they are small and operate in a swarm. So we need diggers. What else do we need, Jeremy?
We need power. Need power on a consistent basis. I'm jumping back ahead to space-based solar power, but
What about chemical plants,
yes,
ceramics, manufacturing, and then power?
we've done a bunch of episodes on space-based solar power. We could link to them in this show, I think, if you want to learn more about it. But that's a tech that's proven and happening now and being tested for further use and implementation down the road. But how do you coordinate, Mark? How do you what are the challenges in teleoperating something from Earth to the moon?
Delay.
How much delay?
It was 2.5 seconds.
2.5 seconds. Doesn't seem like a tremendous amount, but could affect some things, right?
Well, if I have some robonauts, as they're called, we'll call them humanoids now. I'm teleoperating a humanoid from Earth. 2.5 seconds might not seem a lot, but if they're building computer chips on the moon, then 2.5 seconds seems a lot for a very dexterous task. If they're driving diggers around, if they're building chemical plants for volatiles or chemical plants for solids as a need, or refining ceramics, building solar panels, then that 2.5 seconds is a long time. And the solution is the metaverse.
Oh my gosh. But there's that word again. Good Lord.
Virtual reality, the metaverse, the digital twins.
That's dead, right? Like metaverse
Well,
is dead, right?
Their solution
The word
is, they don't say the metaverse. He says resynchronization will occur in the virtual world using a rubric designed to prevent operator confusion. Similar schemes are being developed, but for telesurgery with large communication latency. This will make teleoperation manageable for lunar operations. It will require a growing and expensive workforce of teleoperators on Earth, plus sufficient communications bandwidth, and it will not be extendable to the asteroid belt or beyond.
see the course in Thinking on Paper University, teleoperators for lunar objects.
Start learning now. Get to the front of the job queue. But that is essentially the metaverse. Okay, virtual reality.
Training, that sort of thing could happen as well, right?
2.5 seconds seems to be the limit, though. I mean, you can't be teleoperating these humanoids out in the solar system, even out on the Kuiper Belt. The delay will be too much, which is why they have to be autonomous, self-replicating very quickly. Before we move on to the modeling of the bootstrapping, you've got a lot going on here. It's a very ambitious paper, isn't it? It takes a very ambitious mind to say, you know what, if we're going to go colonize the universe, this is what we need. So when they bootstrap it on a spreadsheet, they kind of makes it all sound plausible.
The interesting thing is when you read something like this, it's a great outline of the potential of a good first step. But then the next step has to be funded. All right, what does it look like to actually do this? And would people want to lean into this? Or are they more concerned with building robots that will help people build cars? And, that'll be novelty items in the front lobby of a hotel that'll carry a drink to you.
Yeah, I would be very surprised if I see humanoids on the moon doing even the most rudimentary tasks. I can't imagine they'll be building water processing plants and then sending that water out to the Kuiper Belt. This is very, very long-term humanitarian goals, isn't it? It's like we said at the beginning, do we want to stay on planet Earth, or do we want to go out and really take ourselves to the universe? And this is what you're going to need. There's a lot of graphs they get into how many robots we'll need. We're talking about 10,000 robonauts by generation 3.
There's a lot of really interesting metrics on there. One thing it got me noodling on is, like you just said a second ago, what are we going to do? Are we going to try as a species, try to figure out how to not fuck up our own house, and stay here and be good? Or do we just say, damn the torpedoes, and who cares about the next generation? This planet's going to be fine for me for the next, 40, 50 years if I'm lucky, right? Or do we look at things like there's a whole nother sect looking at Mars and looking at colonizing Mars? But in order to colonize Mars, have you looked at Mars terraforming? I mean, it's basically like the idea of influencing the existing environment on Mars to force it, to coax it into the environment we have on Earth. So there's issues like
Seeding.
Oh yeah, I mean I think it's a little more than that. But I had Claude pulled up here, and I was like, hey, what do you guys think about space-based manufacturing robot-based space manufacturing and economy versus Mars terraforming. Which do you think has the more likelihood of happening?
From what I know about terraforming, it's trillions and trillions of dollars, and I would say that this is a much more likely scenario.
Yes, the verdict is space-based manufacturing is a better near-term solution, technically more feasible with existing tech. It addresses Earth's emission problem by relocating the sources of pollution, like we were talking about. Manageable timelines, decades versus centuries. This one's funny. This one's funny. It doesn't require making another planet livable.
Since we haven't really spoken about AGI and superintelligence, obviously, of course, during this timeline, artificial intelligence will have got to wherever it has got to. And depending on whose theory of AGI we believe, if those humanoids are blessed with artificial intelligence and they are out on their own, who knows where in the solar system, with infinity ahead of them, they might well start terraforming under their own guise. It's like, oh, we've long since got rid of those idiots back on Earth. Let's terraform.
Yeah, or do they all get together and they're like, yo, we're doing all this stuff for those people over there. Let's go live our own life. Let's get in that. Yeah, that's more consciousness singularity that we're not going to kind of get into here. But let's see. How do we want to land the plane with this one, Mark?
Paper outlines how we bootstrap the beginnings of a space manufacturing industry. It outlines what we need, how we're going to get it. It outlines the challenges, launch costs. It outlines the timeline. The robotic industry in space leads to a grand vision. After the industry becomes self-supporting, it can be sent to other parts of the solar system. The asteroid belt has everything necessary for it: water, carbon, silicate, metals, oxygen, solar energy. Robotic space industry will also bring great dividends back to Earth. The modelling also indicates a significant national security risk. On Earth, the industry of a nation is limited by its resources, including real estate, energy, ores, and the education and size of its labour pool. In a robotic industry occupying a solar system, the resources and real estate are 1 billion times greater. Space industry will fundamentally change the status of humanity in the solar system. Humans are a species adapted to living at the top of the food chain, and we need something analogous to the food chain in space to process its resources. Every conversation we have, this sounds great, but for one small piece of the human pie, doesn't it? Isn't it? Whatever. Jeremy, I want to speak about aliens. I want to speak about Blade Runner. I want to speak about Total Recall. Corp ambition plus exponential tech outruns ethics and government, doesn't it? I mean, Wayland, the company Aliens, it's a mass space-sized, faceless corporate monster. Humanity is left back on Earth, fending for itself. Swarms of autonomous machines, self-replicating, and all the money going back to these giant corporations. That and human nature is the obstacle, isn't it?
Man, I think that's why blockchain is always so compelling, because it's the enablement of individuals against the machine. Maybe, I don't know, but good grief. Yeah, we're going to get
Machines do the colonizing, corporations exploit it, and we're all left back on Earth like in Elysium, as the sun melts the Earth, trying to survive. Well, the powers that be, the 0.1%, sit in their spaceships,
well,
pulling the strings. Right?
Here's where it lies too. You referenced you didn't quite get to the point at the end of the paper where, you know, if one nation or one entity controls the ability of this, it's going to run into the same situation that we're dealing with right now, and this human dynamic, this power struggle, this hey, if I can control this, I can manipulate that. It's carrot, it's stick, it's controlling. And man, I think that's the original problem. Where's the paper on that? Let's go find one on that and figure it out.
We should write a thinking on paper. Or our tech vision, it's all perfect just for one slight problem, and that's human nature. I'm a huge fan of grandiose, massive human ambition. I'm a huge fan of almost ridiculous solutions to our problems. Maybe it's growing up in the era that we grew up. Maybe, I don't know if 20-year-olds of today look up to the stars and look up to the sky and go, we got to be out there, we got to be doing this, we got to be there.
They're looking down.
Are they even looking up? But maybe that's my ego talking, and maybe the 20-year-olds of today do look up, and if you're listening, tell us.
There you have it. I like that finish. It requires a little bit of willingness to be playful and be silly and talk about things that are way beyond our capabilities of today.
So key. So yes, you hit the nail on the head.
So be silly. We're going to continue to be silly, reading some of the papers that are over our skis, but they're very interesting and compelling to solving some of the biggest challenges that we have.
Do you find you might get a silly look if the next dinner party you go to, the next time you go out with your friends, you say, you know what we need self-replicating humanoids with diggers out in the Kuiper Belt mining for ore. We need to make this happen.
I get silly looks every time I talk at dinner parties, Mark. There you have it, Pocket Edition. We're talking about space. We're talking about robots. We're talking about putting about 12 metric tons on the moon, and that'll kick off everything for us. Stay tuned. Hopefully we'll get some of these really smart people that wrote this paper on the show to help us kick it down the line. Mark,
stay disruptive. Be curious.
Keep thinking on paper.